right, now we're looking at Chapter 3. The first question in the Chapter 3 review is describe how you know which side of the line, to shade in an inequality. Well, my game plan, I kind of have a game plan, variable always first, all right? Variable always first. All right, or on the left-hand side. And then inequality points you in the right direction. Let me give you an example. Right direction. So if I had x is less than or equal to 3, you're going to shade that way. All right, if it was x greater than or equal to 3, you're going to shade to the right. You could also said less than is left, greater than is right. All right, so that's another way to know where to shade. So number 2 says graph y equals or less than or equal to 4. So here's our x value. Here's our, I did that backwards. Sorry about that. Our x equation is here, or our y axis is here. So y is 4. Here is where y is 4, is right here. Sorry, there's y is 4. And these are all the different places where y is 4. Okay? So y isn't just a 4, but everything below that. To show that, okay, it could be that 4 or it could be everything below it, what we do is we kind of shade in the big graph that, hey, it could be any of these. So y could be 3, 2, 1, it could be 3.5, things like that. The way that we show it could be or equal to is we have a really kind of solid line here. You don't have to make it solid, more solid than it already is. The way that you show if it was just less than, if it was just a less than and not this little or equal to sign right here, we would have gone through and made little, I guess I would have made them little, I would have made it into like little dash lines like that, okay? All right, so we kind of have dash lines if it's just a less than, not the or equal to. But since we had the or equal to, we're going to make sure we have a solid line. Is 5,1 a solution to this inequality? In other words, if x equals 5 and y equals 1, does it work? Is it true? So y equals 1, we're going to substitute in for this y. 1. Is 1 less than or equal to 4? You kind of ask yourself that question. Well, the answer is yes. 1 is less than or equal to 4, so we have our answer to that question. Now we have another question. Is when x is 3 and y is negative 8, is that a solution? So 1/3 of 3 minus 1/4 of 8, is that answer greater than 8? So we're asking ourselves the question, 1/3 of 3 is 1, 1/4 of 8 is 2, is 1 minus 2 greater than 8? Is -1 greater than 8? My answer is no, it is not, so that is not a solution. All right, so that's a quick way to say, do we have a solution or not? So now we're graphing some equations, and actually we're graphing inequalities. We're going to remind ourselves, how do we graph an equation first? To graph an equation, we start with our starter value. Remember, we've been talking about these starter values in the previous 2 chapters. It's also known as our y-intercept. It's what is y when x is 0. So this represents the point 0, -4. It's what's y when x is 0. So 0, -4 is right here. That's that point. From that point, we know that the change in y is 1 for every 3 change in x. So for every 1 change in y, we change 3 in x. So I went up 1, but I went to the right 3, because that shows my slope of 1/3, change in y over change in x. Again, I'm going to have a slope of 1/3. My next point is going to be right there. Well, I can keep doing that, or I can say, well, the previous one had a change to get to this point. You had to have gone, had to be down 1 and to the left 3. And so I can kind of see my whole line here. Okay? Now here, it's harder to tell what's the change in y and what's the change in x. I think the best way to solve problems like this is to actually find it and put it into y equal, oops, I gotta go back to 5. I'm just realizing I didn't solve 5. Because this was y greater than or equal to. So now it's, well, all the y's would be greater than these numbers. So all these y's that we had, it could be all the ones greater. So we're going to say all these y's could be above it because that's where y gets greater. So we're graphing here where all the y's is greater. And also, we have to have it be a dash line. So I'd go back and I'd probably just do some things to make mine a dashed line instead of it's not a solid line. So we have kind of these dashed lines here. That shows greater than but not greater than or equal to. So sorry about that, I forgot to shade. Got too excited about number 6 here. In number 6, I'd first solve it for y. So I have 3x plus 6y equals 18, and I want the y all by itself. So I'm going to start by adding 3 x's to both sides. I'm going to have to do it over here. So now I have that 6y equals, I'm going to do my x's first, 3 x's plus 18. All right, now I want to get rid of the 6. I want y all by itself, so I have to have each and every term. I'm going to divide here by, I'm going to get more space here, by the 6. So this would be 1/2 x, and you could have written it as x over 2, but I like to write it as a fraction and then an x plus 3. Now I can graph that. Now I have the equation y equals 1/2 x plus 3. I'm going to start at my starter number, my plus 3. This is reminding, this is the 0.03. What is our starter value? What is our y when x is 3? Or x is that value. So when x is 0, what is our y? Gosh, and not only that, I put this in the wrong spot. Sorry about that, guys. There's 3. So there's our 0.03. Then our change in y compared to our change in x. For every positive 1 in the y, I go positive 2 in the x. So that means my next value would be here. Positive 1y, positive 2x, positive 1y, positive 2x, and you just connect the dots. Now, this one does not have a greater than or equal to. It's just an equal sign. So it's just the line there. Okay? The next equation is this x equal 3. Again, this is my x equation, this is my x-axis, this is my y-axis. Where does x equal 3? 1, 2, 3. This is where x equals 3. But x equals 3 all along here. Not just there. Alright, so x equals 3 all along this line. And it's all the different y's you can have. And really the y doesn't matter. So it's just, and I'm sorry, I should have a nice straighter line than that, but I don't. But it should be just the vertical line at x equal 3. Alright, so it's some more here. I'm going to go ahead and just solve number. So you're magically going to see here, you saw some things up here. I subtracted 3x from both sides here. I then took my equation and I divided everything by 5. And I got my equation. So let's look at how we graph that. Starter value is at 3, 1, 2, 3. Here's our starter value when x is 0, y is a 3. The change in y over the change in x, it means y goes down 3 for every time x goes positive 5. So down 3, 1, 2, 3, and I'm going to go 1, 2, 3, 4, 5, positive 5. Where would I have had to go? There's really nowhere else to go down 3. I'm not have places to go this way. So what would I have to have been at to get here? I would have had to have been up 3 and 1, 2, 3, 4, 5 to the left to have it go down 3 and get 5 to get to this point. So it really does help to have 3 points before I draw my line. Now I have an inequality. Alright, so my original problem here had this inequality of y is less than or equal to. So the values that are less than, the y values that are below are less than. So here this y value is at a 0, but below would be everything down here. And so we're going to shade in the bottom area below our line. And it would be a straight line, a solid line, not a dashed line because it's or equal to. In this problem here, I had to go and I had to divide both sides by a -3. Now, dividing by a -3 made the big rule kind of take place, which means when you multiply or divide by a negative, you're going to switch your inequality. And I did that. I switched my inequality there. So I have now y is greater than a -4. So I have to decide where in the y, here's my x, here's my y, where in the y do we have -4? 1, 2, 3, 4. Here's y is -4. And no matter where x is, these are all still y is -4. And the y value is actually greater than that -4. So what are the numbers greater than the -4? Well, -3 works, -2 works, and it's like this line works, this one works, this one, and it's really all these lines work. So we kind of just shaded it. And what we have here for our original line, it's just a greater than, it's not a greater than or equal to, so technically this line doesn't work, so we would do this dashed idea. Let me kind of make a nice gentle dashed line there. Now we have an equation here, starts at 3, 1, 2, 3, has a 2. Well, we deal with that and we make that 2 into a fraction because we have to know a change and compare it x and y or y and x. So for every time the y goes up 2, the x goes up 1 or to the right 1. 2, 1, or if we went down, it'd have to be negative, down, negative, and down, negative, because like kind of have to do this logic of where would we have been. This is an equal to sign, so it's the line that is representing this equation. All right. So now we're solving a system of equations by graphing. What we have to do is we have to solve both of these equations for y. So here, in order to get the y all by itself, I basically want this 4x on the other side of the equation. So y equals a positive 4x minus 5. So to bring the 4x to the other side, it changes the inequality, or changes the sign, not the inequality. Sorry, there is no inequality. Here, this y would equal a negative 2x plus 7. It changed it from a positive to the negative. When it jumps over that equal sign, it changes. It's kind of like I subtracted 2x from both sides. Now I have to graph these two lines. I'm going to graph one in red and one in green. Let's start with red. And we'll do this one as my red one. We're going to start at negative 5. 1, 2, 3, 4, 5. And it's considered 4 over 1. So it means for every 4 I go up, I go 1 to the right. 1, 2, 3, 4 up, 1 to the right. Now I can draw my line. There's my lovely line. Now, let's do the other one in green here. This will be my green value. Now I start at 7. 1, 2, 3, 4, 5, 6, 7 right here. And now for every 2 I go down, I go 1 to the right. 2 down, 1 to the right. 2 down, 1 to the right. All right. So I can graph that. Now it says, what's the solution? The solution is, what one point do these two lines have in common? I don't know, anybody yelling it at home? This point right here, here it is, I could see it, that's the only thing they have in common. That is the point 2, 3. If I go 2 over and 3 up, I get to that point. So that's the point 2, 3, and that's what they have in common, and that is my solution. The way you can check that, you can see when you put in 2 for x and 3 for y, are both of these, my red and my green equation, true equations. And yes, they are both true equations at the point 2, 3, and so that's how we know, hey, we got the right answer. So let's do another one. How do we have this solution? Well, again, I have to, this one I've already gotten the terms that I want. I have to move this one around. I'm going to move that 6x to the right side of the equation, so I'm going to make it a positive. I'm going to do the same process. I'm going to make this my red. 1, 2, 3, 4, and it goes up 1 over 1, up 1 over 1, up 1 over 1. Because it has a 1 for a slope, that means up 1 over 1. Now let's make the other one my green. I'm here at 1, 2, 3, 4, 5, 6. All right, now I go up 6. 1, 2, 3, 4, 5, 6 over 1. Up 6. 1, 2, 3, 4, 5, 6 over 1. All right, so we have this equation. And hopefully now you can say, hey, they meet right here. I can see it. You're over at 2. 1, 2, 3, 4, 5, 6. 2, 6. So our equation is at, or our solution, sorry, is at the point 2, 6. Very cool indeed. One more. We're going to check by substitution. I think I have a time to do this. Substitution means instead of one value, you can plug in another. Here it's telling us y is this. Y and that are the same thing. These two are equivalent. So instead of this y, I can plug in negative x minus 8. So I'm going to plug that in to the whole equation. And now I only have x's. It's kind of a beautiful thing that we can solve it with just x's. I have to do distributive property to solve this, so I have negative 2x plus 16 equals 9. Negative 3x. Combine these two, I have negative 5x plus 16. All right, so what I did here to solve these, you'll see some work kind of magically appeared. I had to first subtract 16 from both sides, divide both sides by negative 5, and I got my answer of x equals 5. Here, I had to first take this and I had to say, okay, my y is really equal to 4x plus 16. Then I had to substitute that in here. So instead of this y right here in this equation, I substituted in 4x plus 16. And I was able to go through and solve it. All right, so I substituted in, I did the distribution here. And then I subtracted 48 from both sides, divided both sides by 6, and I got x equals negative 5 halves. Let me look if this is it. Nope, we do have some more. I want to go over, we'll have another video that has to do with elimination.